Today you're going to be watching a review of Chapter 8, Geometry. I created one slide per lesson so that you could go back and refer to this as you complete your homework. As you know, your homework will be the same assignment for 3 days. You should complete about 10 problems per night, and if you need to go back and review, this is a good review video to scroll through and find the problem that you might need support with. In Lesson 1 and 2, we learned about circles. We learned about finding the circumference and area of circles. In Lesson 3, we learned about finding composite areas, which are areas of combined simple shapes. In Lesson 4 and 5, we learned about the volume of prisms and the volume of pyramids, which is a three-dimensional measurement. And in Lessons 6 and 7, we learned about the surface area of prisms and pyramids. In Lessons 1 and 2, we also learned about the parts of the circle. We saw that the radius is a line from the center to the edge of the circle, and it's always half of the diameter. The diameter is the long line that goes through the center of the circle from one side to the other. And then we talked about the circumference. The circumference is the distance around the circle. We find the circumference with the formula circumference equals pi d, or 2 times pi times r, 2 pi r. We also learned about the area, or the area of the circle, and it's found with the formula pi r squared, or pi times r times r. In Lesson 3, we looked at the area of composite shapes. To do this, we needed to know how to find the areas of simple shapes. So here are the formulas for simple shapes that you can refer to when you go to solve with simple shapes. So on this example here, we have a composite area. First, we draw lines to separate the composite shape into multiple simple shapes. You notice that we have 3 shapes in this composite shape. On the left is a triangle, so we find the area of the triangle with base times height divided by 2. In the middle is a rectangle with an area of length times width, or base times height. And we also have a parallelogram. Notice on this shape they did not give us the height of the parallelogram, so we need to refer to the bottom line drawn under the shape that shows us that entire length is 16. So we see that that's composed of 7 plus 3 plus the height of the parallelogram. So from this we know 7 plus 3 plus h equals 16, so the height must be 6. Next, we find the sum of their combined areas, and that is the composite area of this shape. In Lesson 4, we learned about the volume of rectangular prisms. We remember that the basic formula is area of the base times the height, which would mean length times width times height because the base is a rectangle. We label this with centimeters cubed because volume is cubic space. Next, in Lesson 4, we also learned about the volume of triangular prisms. Notice that a triangular prism is half of a rectangular prism. The volume of a triangular prism is equal to half of the volume of a rectangular prism. So the formula would be length times width times height divided by 2. Again, we substitute and solve to get 120 centimeters cubed. In Lesson 5, we looked at the volume of rectangular pyramids. In the video with the water, and when we were pouring water from pyramids into cubes with the same height and base area, we found that the volume of a rectangular pyramid is always 1/3 the volume of a cube or rectangular prism of the same height. So we have length times width times height divided by 3. And we solve by substituting. Always multiply the top and then divide. If you look at a triangular pyramid, again, a triangular base is half of that of a rectangular base. So if we look at the formula for a rectangular pyramid, length, width, height divided by 3, and we take half of that, we would get length, width, height divided by 6. So then we would substitute and solve for the volume of a triangular pyramid. Next, we talked about surface area, and surface area is different from volume because it's only measuring the outside area of a shape. So think of a box. If you unfold the box, you have found the surface area using a net. So here's a rectangular prism. If you notice, the bottom and top have the same area. The left and right sides have the same area, and the front and back have the same area. So to calculate the surface area, we can do 2 times the bottom, which is length times width, plus 2 times the side, which is width times height, plus 2 times the front, which is length times height. When we substitute and solve the numbers, we always multiply first and then add the numbers in the parentheses. So multiply the numbers and then add in the parentheses, and then multiply that all by 2, and we have a final answer of 256. The surface area of triangular pyramids or prisms. If you look at this prism, again, prisms have 2 bases and rectangular faces. So we would find 2 times the area of the base plus the area of rectangle 1 plus the area of rectangle 2 plus the area of rectangle 3. That would give us a combined surface area for this prism of 312 centimeters squared. Next, we can look at the surface area of pyramids. Again, we're going to unfold. We could unfold and find the area of each piece, but we are using this formula, the area of the base, which is the area of the square, plus the perimeter of the base times the slant height divided by 2. We just substitute and solve the values. Notice the perimeter is 5 plus 5 plus 5 plus 5, or 20. On triangular prisms, again, same formula. Area of the base plus the perimeter of the base times the slant height divided by 2. If we substitute and solve with the numbers given, we find 121.2. Okay, so that's a quick overview of solving for all of those different types of shapes. When we're completing geometry questions, we have certain steps that help us. First, we want to know what measurements are we solving for. Once we know what we're solving for, we should know the name of the shape. Is it a circle, a prism, a pyramid, and what is the base shape? We use the formula sheet to find the measurement and the shape we're solving for. We write down the formula. Do not skip this step. Then we substitute the values of the dimensions given into the formula. Be sure to look carefully at the dimensions and label them appropriately, or the whole problem will be incorrect. Then we solve using order of operations, use a calculator to be accurate, and label the answer with the correct unit of measurement. If it's circumference or perimeter, we solve with units because that's a measure of length. If it's area or surface area, we square the units because area tells the number of squared units. If we're solving for volume, we use units cubed because volume is a measure of how many cubic units we could fit inside of an object.